right, so I'll switch to English. Hello, everybody. Thank you so much for coming. Super cool. The title of my talk was a bit different, and the scope as well. So I was supposed to be talking only about DHTs, distributed hash tables, but I'm going to be talking about peer-to-peer in general. I think it's a bit more interesting, so let's see how things go. Although I'm going to still focusing quite a bit on DHTs as well. My name is Gonçalo. I'm a computer engineer. I've been working with a lot of back-end systems development, and recently I've been focusing on peer-to-peer networks, privacy-preserving networks. And this is sort of a subset of what I've been working with lately. Yeah, let's see how it goes. I've got quite many demos, like 3-4 demos, but then again, I don't know if the wireless, if the internet will help us with that. Otherwise, we just talk through it. And by the way, I would really prefer to make these turn these into a conversation. So please feel free to ask questions and to interact. I really hate to give talks, and be talking, like one-way talking. I really hate that. So if you have any question, if you have any other question which is not related whatsoever with what I'm talking about, just feel free to ask. I've got 1 hour slot. I hope no one of us have to, suffer through 1 hour. I really hope. So let's try to speed up things as well. But anyways, feel free to ask stuff. All right. So again, we're going to be talking about privacy on peer-to-peer systems. We're going to kind of roughly define what that means later on, but this is basically what we're going to be talking about. So giving a bit of context in the beginning, because we're talking about security, privacy, we're going to define the threat model. Basically, what are the threats when using peer-to-peer in terms of privacy? We're going to even kind of talk about why is this actually important and so on. Afterwards, we're going to see why everyone is naked when using peer-to-peer. So why should we actually be concerned? And that's exactly where the demos come into play, because I really want to show that how current systems are already deployed and people are actually using them while disclosing all this private information. So that's kind of the main goal of this talk, is to understand how you can go home and start to figuring out yourself, try out to get, information about other people that you should not, probably. Super easy examples, not anything too sketchy. And then we're trying to put the clothes on. So what are the protocols, what are the techniques, the mechanisms that we can use to actually protect ourselves when using peer-to-peer technologies. Okay, so this is more or less the idea of the talk. Let's get through. So if you're in a rush, if you don't want to listen to me for the next half an hour or so, I'm going to try to summarize everything in basically 5 minutes, and then you can go away. Or hopefully you're going to be super psyched to stick around. So peer-to-peer systems, basically the very interesting concept, or the very interesting result when talking about peer-to-peer, is that it's sort of a mindset or a set of technologies and protocols that help us to build very scalable, with high availability systems, right? Be it centralized or decentralized. And we're going to be talking about what that means later on. So basically, that's why this is so important, right? We're talking about technology that really, really helps us developers, system designers, to build the scalable systems we're going to need in the future. And it has also been the bread and butter of this new paradigm where people and community are very into decentralized systems, right? So basically, networks, systems which do not require any central authority or central a source of truth. And we've got examples like Ethereum, Bitcoin, Ipfs, and many of those. So basically, how can we basically deliver the same or even better services as we've got Facebook, Amazon, and whatnot, but in a way that there's no Facebook CEO or Amazon kind of entity controlling the whole interaction between peers and users. So basically, that's where peer-to-peer really fits well, because now we're concerned about the communication between different entities talking the same protocol in order to achieve a goal, right? So that's why peer-to-peer is so important. And this sort of a new mindset or this new model really can only work if we've got a lot of collaboration, right? So the peers, because there's no one mediating the interactions between the different users, there's no Facebook to receive my message and deliver to my friends. There has to be a lot of collaboration between the different peers in the network or between me and my friend. So there's where like a very interesting kind of mind shift when talking about peer-to-peer is that we require a lot of interaction and collaboration between the peers. And that's exactly the problem, right? So it's a very interesting kind of situation because what brings the best of the peer-to-peer networks is also what on a privacy perspective brings the most danger, right? So that's a very interesting sort of idea, and it's basically like in centralized systems, when we've got like client server models, you've got a lot of peers, a lot of users disclosing information to this one central authority. So basically, we're all disclosing data to Facebook about our social graph, about our interactions, behavior. But if we try to make a decentralized Facebook, what happens if the technology is very like naively, or if it's not well thought through, you're actually disclosing that information to potentially thousands of people, right? So that's like really what we're trying to avoid here. And yeah, I mean, and another interesting point is that it's very hard, very complex to solve that, right? So that's the other take from this talk is like, it's very hard to do that. And then again, it's already hard to sort of fight or sort of compete against the centralized systems. It's even harder when you put privacy into consideration, latency, everything. We're going to talk about that later. So yeah, my starting point is privacy. I really believe that sort of privacy is one of the most important things. Privacy online is one of the most important things for us to keep running a somewhat free world and society. And then from then I just jump into, okay, we can only get these through the centralized technologies. But on the other hand, if we're not careful enough, it's making everything much worse. So yeah, that's basically it. And we're going to see some examples and whatnot. All right, a bit of context, right? So very quickly, I don't want to spend too much time here, but so that everyone's on the same page, I'm going to be talking a bit what in this talk these concepts mean. Then again, this is like very broad, or this is a very brief definition of these concepts. So this is just to be able for us all to follow the conversation. So what a distributed system is, it's basically a system in which the resources are, so the nodes, the content stores, the computation are basically in different network locations, right? And there's some sort of orchestration, and that can be done through entity, sort of a centralized entity or not. It's basically like we've got a lot of, basically all the big systems nowadays are using a lot of distributed systems, right? So it's impossible for one machine to be responsible to serve Facebook or Google or Amazon, right? So we've got to orchestrate a bunch of nodes deployed around the world so that we have scalability, reliability, and so forth. So this is when I'm talking about distributed systems, this is what it's going to be. Then we've got the centralized systems. So basically, it's a subset of distributed systems in which there's no centralized authority or truth or center of control, right? So basically, peers are all trying to achieve the same goals through protocols and through communicating with each other. And then we've got peer-to-peer, right? So sort of a peer-to-peer is a bit of an orthogonal kind of field, technology, in a way that, then again, for having peers or nodes in different parts of the network collaborating with each other, being controlled by a centralized authority or not, we need these sort of peer-to-peer protocols. So, yeah. Now, also, what does privacy mean? This is another interesting thing. Like, a lot of people talk about privacy and talk about, and kind of think that privacy is all about encryption. And then we see, for example, WhatsApp saying, yeah, we've got end-to-end encryption, no backdoors, you're all good to go. I think that's a very skewed way of looking at privacy, right? So basically, we've got also what we
you probably know as metadata. So, and metadata is very important when it comes to privacy. So, metadata is actually the data that describes other data, right? This is like the broadest definition of metadata. So, for example, HTTP header can be considered the metadata, right? So, it actually, it's the information that describes what the payload of the HTTP packet is. That's an example. We're actually more concerned about relationship information. So, the idea is that if I'm talking to Simon, for example, in front of me, and we're talking in German, for example, and no one here in this room knows German, we're sort of having a encrypted communication channel because no one understands what we're talking about. But every one of you can see me and Simon talking together with each other, right? So that's metadata being disclosed through this interaction, right? And you can probably already think that this is very interesting, and it happens a lot in peer-to-peer systems, because even if everything is encrypted, there has to be communication between peers which are interested in each other, and that's metadata. So if your guys are able to see that we're communicating, even if you don't understand, you know that I'm somewhat interested or having a relationship with him, right? So that's like what metadata will mean in this context. So yeah, this is basically what I was talking about. In this case, Mallory can probably not understand if the channel is secure, completely secure, encrypted with asymmetric cryptography, super secure channels. The secret is shared and no one knows. Mallory still knows that they're talking with each other, usually. So yeah, I mean, privacy is not only about encryption. It's not only about the content of the conversation, but also the fact that the conversation happened, right? So that's like what I would like to take, like the main message to pass here. And privacy is nothing else than a kind of measure, so we can see it as a gradient of how much information and metadata is disclosed when in any context that you might think about, right? So that's basically sort of our starting point. These are our definitions. It's a bit more complex, like all of these definitions are more complex than these, but I guess we could just have 1 hour conversation about each of these, and that would be no fun. So let's just skip that. And that's also like, another important thing is that many times when I talk about metadata with other people, people are like, who cares, right? Who cares? I mean, as far as they don't know that I'm talking with my mom, it doesn't really matter if people know that I'm talking with my mom at 3 a.m. at night. And that's kind of true. But on the other hand, like metadata does disclose a lot of data, and there's a lot of information one can infer from those communications. One very good example is this guy. It's a former CIA director, and he had like this very interesting, I think this was like in a panel. It was recorded. It's on YouTube. It's very interesting. You should definitely go ahead and look it up, the talk. And he just, I don't know if he on purpose or just slipped from his sort of a thought process, but yeah, I just said like, we at CIA kill people based on metadata, right? So basically we can target individuals and also communities based on metadata, not even the data, but the fact that this person is talking with this person, or this person is accessing this website at a certain time. So basically, this kind of information is actually being used to kill people. And as you may imagine, we don't need to be as extreme, but there's a lot of like a spectrum of things that can be done based on metadata. So yeah, it's an important thing, and people often overlook these, and I think it's one of the most interesting parts, exactly because of that. All right, let's talk about the threat model. So again, because we're talking about privacy, a bit of security as well, it's always important to sort of put it out there. What is it that the adversary does? What's a threat model, right? And also a bit why is this even important? So again, peer-to-peer systems can be seen as a bring your own node network, right? So you join a network, you not only consume resources from the network, but you also usually give resources to the network. So basically, you can come in, ask other nodes in the network to store your own data, but at the same time, you can also store data from other people, right? And the really interesting thing about this is that people need to rely on others for a goal to be achieved. And because we can imagine that we can try to have a kind of global view of what's happening in the network in a way that, okay, I want a resource which is stored in the network, right? So if I want this particular resource, if I know where it is stored, it's easy for me to just go and ask. But the problem is that as networks grow a lot, it's impossible to keep like basically the complete global view of what's happening. So what's happening is that a bunch of interesting protocols that skew that in a way that you've got a partial view of the network, and these partial view will help you to find where things are through protocols. So, and that's exactly what happens. So if for example, the red, as you can see in the image, if the red circles are sort of adversary nodes, and if they are in between this sort of a resolution protocol, they can actually know that one of the nodes is trying to contact other, right? That's sort of a like very, very high level, the problems of, for example, DHTs, right? But yeah, anyways, in terms of thread model, what we're really concerned with here are local passive adversaries controlling up to 20% of the network. Okay, so what does this mean? It means that we're not concerned with governments, so basically, or big corporations, big institutions that can see and basically every flow in the network. So, and then can kind of link things together because they have so much information about what's happening. What we're concerned in this talk, that's, by the way, yet it's another ball game, very important as well. For example, Tor, it has a bunch of, the onion routing has a bunch of like vulnerabilities exactly because of that. If a person has enough view of the network, he's not going to be able to have like anonymous communication. Anyways, we're not concerned with that problem. We're just concerned with the peers which are in the vicinity, right? So that kind of makes the problem a bit easier, but at the same time very interesting, as we're gonna see. So the adversary is passive, so basically it will not try to change any requests. It will just behave as a normal node, but will try to infer what's happening. And controlling them to 20% of the network means that if the network has 100 nodes, the adversary controls up to 20 nodes and sort of scatters around the network and tries to understand what's happening. Yeah. And then again, the adversary should not be able to learn other nodes' behaviors, interests, social graphs, etc. So this is basically the threat model. And yeah, this is the thing. Like, we can see, I hope you can see the letters in the graphs, but the idea is that the red nodes, the M node, which is red, I don't have my thingy here, can actually, it's in between interaction of different nodes and can learn that these nodes are interested with each other. Okay, we'll see how things work a bit further off. But yeah, this is what I was talking about before. Like with peer-to-peer systems, we get into a system, or it's sort of a network or a sort of a relationship in which we can think of as of people shouting at each other in a way, because we need to collaborate with each other and we have a reduced view of the network. And that leaks a lot of data, and we don't want that. Okay, so now let's go for the demos. The idea is that I'm gonna show how peer-assisted content distribution networks leaked a lot of data about basically anyone here who starts working this service, which probably everyone is using, by the way, without us even knowing, and then DHTs. Okay, so what are peer-assisted content distribution networks? This is going to be sort of a short introduction, and then we're going to go for the demos. So the idea is that, as you know, most likely, well, people nowadays are consuming a lot of videos, a lot of content on the edges. So basically, when we're streaming a video, be it a football game, match, or whatever, we're actually downloading this data from a server, right, most likely. The problem is that as the amount of devices increase, the quality of the videos increase, there's a lot, it's very hard to actually scale this up, especially when there's like, I don't know, the final of the World Cup happening, and then there's like thousands or millions of people streaming very high quality content. So like the services that nowadays provide this caching don't want, or it's very hard for them to actually deploy the servers closer to the edges as they would like to. So this is very like interesting Because as you can see in this example, in this small diagram, we have the viewer 1 sort of streaming the content, and then the viewer 2 maybe streaming the same content from the sort of the server cache. But what kind of peer-to-peer allow us to do is to think that, okay, if a host close to me has already downloaded that, why am I requesting the server again? Why cannot just get the content from these other peers? So that's basically what happens with these peer-assisted CDNs, right? So again, if I'm streaming data, if my sister or my brother are at home streaming the same data, why should he or she ask that same data from the server, just go all around the network for the same content? Why am I not myself like providing that data to him or her? And that can be done nowadays, and it's actually been used in very successfully and with a lot of gains in terms of bandwidth and whatnot. So the idea is that the server still controls and knows who has which data. So this is sort of a centralized service still. It's not a decentralized service like Bitcoin, Ethereum, or whatever, but it is using peer-to-peer technology to sort of distribute content. And that's very cool. It's very scalable. It's like, I think last time I've read, there were some of the CDN providers having a gain in like 92% less, 92% bandwidth consumption, just because like there's peer-to-peer exchanges of data. And I think that's super cool. Yeah, but there's a big problem with that. And if you think about it, if I'm storing a video that I just streamed in this building, and then someone else in the building is actually interested in the same video, they're going to ask for me, and I can see all that connectioning happening. So there is a bunch of cases in which this can go wrong. Obviously, no one cares about football, in a way. You can think of, just to sort of motivate a bit, you can think at a very high level, if a streaming system like this is being deployed in a country where there's some sort of a dictatorship in which the government really tracks down or tracks down whoever are sort of opposition or have opposite ideas about who's in power and whatnot, it's very easy for them to sort of cache that content and then start distributing it, and then understand, try to resolve the IP addresses and whatnot, and then track down who are the dissidents and try to, you basically can stagnate the whole nation based on that, or in terms of social progress and whatnot. So yeah, and basically we're using this technology, and many of us don't even know that we're actually disclosing that information. And again, we might not have that many things to hide, but we never know. All right, so let's summon the gods of all demos. I'm a bit skeptical about this demo because there's not much internet. Let's see. So the whole idea, and it's very actually the providers of these peer-to-peer CDN are very cool people, and they have really nice ways of showing how this works. And even if the demo doesn't work, at least we got a good graph of how it works. So this is the VibeLast website, and it actually shows very well. I don't even know if this is production data. I hope it is, but I don't think so, because the IPs also look a bit funny. But then again, the idea is that the server is here in the middle, kind of, and different peers, different nodes with different IP addresses are requesting data from the server, and then eventually, wherever other peers want it, they just send it sort of in a peer-to-peer fashion. That's basically what we talked about. So what we're going to try to do, bear with me, it will most likely not work because I just tried 2 hours ago in this network. But the idea is that I'm going to use this cell phone to download. It's actually, again, very handy that they have a demo. Another company has a demo, so I don't have to be setting up servers and stuff like that. So basically what I'm going to do is to use the demo in the StreamRoot service. So I'm going to start streaming from my cell phone, from my own 4G, this video. And then I'm going to wait a bit. Actually, I'm going to start that now so that we don't have to wait too much. And then the idea, and it's very unfortunate that I cannot show what's happening here, but I mean, no big deal, I guess. You all can believe in me. So the idea is that after a while, I'm going to start streaming from here. And supposedly, if the network is good, we're going to see that actually I'm going to start using Wireshark to see what are the communications happening. And then I'm going to see the IP of this cell phone. And that kind of discloses who is actually consuming the same data. And then again, this is something that can be done in 5 minutes, maybe less. Obviously, if it was a really targeted attack to communicate to the person, it would take a bit longer. But this kind of shows the idea behind of what's happening. So let's see if I can even start streaming. Actually, I'm streaming now. That's good. You probably cannot see what's happening, but the video will start. Let's wait a bit. We can start. This was actually capture from a bit long ago. So this is not from now. We're going to start a new capture, save. No, sorry. So this is Wireshark for those who don't know. So this is basically what I'm trying to do. This basically shows like a bunch of different network packets from a bunch of protocols that are going through my wireless interface, right? But there's a bunch of things here. So like TCP, et cetera, UDP, NBNS. I have no idea what's that. So what I'm going to do is, I know that this protocol uses DTLS. So I already know that because I've done this before. So the idea is that if now I start streaming from my web browser, supposedly, if everything works well, then again, the network might be blocking some of the TCP connections. Basically, it might be blocking a lot of like the peer-to-peer used kind of ports as well. So if it all works well, it's going to start using these as the cache instead of the CDN. So let's see how things go. Which one was working? Okay, we go to the demo. So this is basically going to start streaming. In the beginning, we see 2 users because one of them is here. Maybe someone else is getting in. That's good. It's now streaming the same content, and it's streaming from the CDN still. So the beginning is always like taking data from the CDN, and then eventually, if this actually works, it will start using the stream root DNA, whatever. And the idea is that once that happens, so basically now there's this sort of a protocol between the CDN trying to understand, okay, this laptop is requesting this data. Is there any peer close to him in terms of location that is requesting or has the same data? And that's, I think, where things go wrong in this demo because there might not be a way to kind of get these guys to connect with each other. So both of them will only be requesting the content from the CDN. But anyways, let's see. So basically here, I've got all the DTLS packets. And I'm still, let me check my IP address is something like 10.201. Yeah, so this is me, 10.201. So it's still requesting 83.223. I think this is a Amazon box, so it's a CDN box. And as we can see, there is no, or is there? I would expect no. So as we can see, we're still downloading, although this guy is also downloading from CDN, we are still downloading here from CDN as well. Because then again, I think what's happening here, and this is not working as expected, but you can try this at home. I think what's happening is that the CDN is asking the laptop, hey, connect to this IP address and start getting data from him, right? But then he tries to connect, but it doesn't manage, so he keeps taking data from the CDN, right? So that's how it doesn't work, I believe, because of the network configuration. Welcome to the peer-to-peer world. That's another thing, super hard to get things to work across firewalls, across NATs, across everything. But yeah, the idea is that what you would start seeing, if everything would be correct, I should have recorded this at home, by the way, but anyways, is that eventually when we start streaming from here, we would start seeing my IP address as the source of the content. Basically, that's it. And then from then, you can look up the IP address. Many times, you can actually take a lot of information just based on the IP. And that's like, again, based on our threat model, this is no good. Because I know that the guy who's in front of this laptop knows that this guy is interested in the same content. And that's like a data point, sort of a metadata point that we're taking. So this is widely used nowadays. A bunch of services are actually using this, and it's, in my opinion, super sketchy. No one talks about this. It's bad. It's not privacy preserving. It's very bad. Then again, this is a central service, and you can try this at home. And it's very fun to go around and see what websites are actually using this. And you can think of, for example, I don't know, a lot of data that I don't want to disclose about myself, but then my neighbors go around and try to know things about myself, and they just start streaming a lot of their own data and try to catch if I am actually getting that content as well. So this is one of examples of how it can go wrong. Okay, so this is with the peer-assisted network. So yeah, sorry, no, if I talk to each other and get drunk. This was already, okay, this is not gonna work. And we've already talked about this. This is one of the metadata points that we can get through a peer-assisted content distribution. Okay, it's a big mess, right? We can see that from this small example, how things can actually extrapolate to much like dangerous situations, especially when we have so many people, and I think I'm one of those people trying to push this technology forward. Especially as it becomes more and more mainstream, it becomes also more and more dangerous. So yeah, this is one of the problems that we gotta solve eventually. Okay, second example is a complete decentralized system, right? Now DHTs. Then again, as I said before, the talk was supposed to be only about DHTs, but then I also thought that it would be nice to see it's not only the centralized technologies that are leaking this data, but also centralized that are being used a lot nowadays. So let's go for the DHTs. DHTs, I'm gonna try to explain what a DHT is in like one slide. It's gonna be cool. And basically, it's the goal is to create a network, right? So like a bunch of nodes, which again collaborate with each other, in order to create a key value store, or abstract it as a key value store. So there's an API, right? So you want to store some content in this network. You just ask the peers around you, hey, store this content, right? And then they will figure out where to store. And by where, I don't mean some warehouse in Amazon's data center, but rather this responsibility is shared across the nodes, right? So there's a way to in a very deterministic way to know in which node of the network are responsible to store a particular data, and also which makes it very easy to route that data when it needs to be stored, and vice versa to get it back. So trying to make this very, very light, the main idea I think, and that's where I kind of changed my mindset, is that you've got let's say 1,000 nodes in the network, and you've got a lot of content, that's arbitrary content to store in that network. And the interesting thing is that each node has a unique ID, which shares the domain space as the content ID. So this means that, for example, I have a PDF file. I'm going to hash the file to get the ID. And that ID, I know that there's someone in the network which own ID is either the same or very similar, very close to that, because they're sharing the same sort of a namespace, right? What this means is that every time I'm storing my PDF, everyone in the network knows that the node responsible to this PDF is the one which has an ID close to it. So this makes it possible for me to say, hey, okay, just store these in a place that everyone else will know where it is, because the protocol is deterministic. Yeah, so that's sort of the main idea. And then the other very important thing is that we maintain sort of a list of other nodes distributed in the network in a way. There's different ways to distribute those network nodes, or to have it maps that are able to jump from place to place in the network. So I want this specific ID to make a lookup of this specific ID of this content. So I just ask the ones close to me, and they will know some other node which is closer to this content than the one I have.
and then this sort of goes recursively until the correct node is reached or not. So that's basically the main idea. I don't know, I hope it's like, if you can understand, but the main point is that I, as a peer, am responsible to store some data, right? And I'm also responsible to help other peers to find that same data in the network. And then through this protocol, which might be different from flavors of DHT to others, we kind of communicate with each other, hey, I need this, I need to know who do you think is closer to this object, because my other friend is asking for that, stuff like that. So this is very interesting and very powerful, very scalable, sort of a peer-to-peer sort of a protocol, and it's been used by many many projects and many networks. We've got IPFS, which is like super cool, and they've been using it very successfully, basically to store content addressable resources. We've got also BitTorrent, which everyone probably know. So basically, if you want to get some movies and stuff like that, I don't think you should do it, but there's a lot of the interesting thing was that, for example, back in the days with Napster, when there was this central server which was storing all the musics for people to sort of download in an illegal form because it was copyrighted, the government just went there and shut it down. And that's basically it. Napster was down because they knew the guy who was storing all the content, or at least the tracker, not the content, but the tracker. So basically they had the list, they knew who was responsible for the different nodes. But then like smart people understood that, okay, if there's one place in which this mapping is sort of stored, it's gonna be very easy to take it down. So why don't we just distribute this protocol? And that's exactly where a DHT is a very good kind of, fit, because it's not one person or a set of people or users in the network that know where the content is. Basically, everyone can resolve and can be part of the storing and caching the content. Yeah, so we've got IPFS, we've got that. I2P uses DHTs. It's not completely based on a DHT. BitTorrent is a very good example. Yeah. And we're going to be actually showing, because IPFS, I think it's like, they really work very well. And they have also like a bunch of interesting sort of a tooling around the DHT that was created for storing data. So I'm going to use IPFS as a demo sort of example. So I'm going to show a couple of examples on how actually IPFS, because of this protocol, is actually leaking a lot of metadata of what their users are doing in the network. Does anyone have any question? Like, really don't feel afraid or anything else to ask. Even if you consider this a dumb question, just go ahead. It will also help me to kind of drive the conversation towards where you think is the best. Okay, so again, let's summon the gods of the best demos ever. And I'm already expecting the things, oh no, this is the wrong title. The things will go wrong in terms of internet, network. I've tried this before, didn't work. Just, at least in this network. So I hope you can see, can you see well? I can actually put it a bit bigger. Increase a bit, all right. So for now, we're just, am I connected? I am. So we're gonna see what's happening here at the end. So this is basically something that we take a bit of time. We can see that everything is failing. We're coming here later on. So basically what I'm doing here is to create a node in the network and just make the node kind of outputting on my terminal every single request, every single protocol request that goes through me. So basically I can actually map resource ID, which is in the network, and a person and an IP, and know that this guy or this person is interested in this content. So basically that's the idea. The other demo that I have, and maybe, yes, let's go that one. This is a very cool one, and I really like this one. And
there was a very interesting GitHub conversation about this one, which I can link afterwards. So one of the very cool things about, for example, Ipfs, DHTs in general, but Ipfs, is that you can basically store your website in a complete decentralized way. So instead of storing it at, I don't know, Heroku or Amazon, and then have these guys like responsible for storing and serving the content, you can actually ask the whole network, hey, can you please just store this content on my website? And then whenever people come and want to see the website, instead of asking to a central authority, it will ask the network. So that's very like resilient to censorship. That's very, you're basically owner of your own data. There's a bunch of interesting ideas behind storing your content, your website's data in a DHT, in a network like Ipfs, rather than on a centralized. So the example exactly this. So I've got a HTML page, very simple. It's my web page. We can see it here. So it's basically this. I'm a software developer, huge advocate for peer-to-peer and decentralization. So what I'm going to do is, first of all, use the Ipfs tooling to add my website to the web. So basically what I'm doing is this, hey, network, please store this content, right? So what I'm going to do is, I'm going to just make it a bit bigger, Ipfs adds index HTML. So it couldn't be easier than this. I'm actually, by the way, here. I was not even, yeah, but this is already there. That's why it worked. Anyways, I'm already running the daemon. So this is basically my personal node in the network. It's working on the background, taking care of all the requests from me and from other peers as well. Anyways, okay, so I added the web page. And then the cool thing is that if I go ahead, I'm going to stop this because of the gateway. If I go ahead and, for example, use a gateway to check the content, so this is the ID of the web page, I will probably get it. No, I will not because no one is on. So my node, the one that I just initiated now, is caching the website. So here I'm asking the gateway to resolve the website that I cached in Ipfs. What's happening now is that it's asking Ipfs to nodes, hey, do you know the guy who has this content? And it's going to be my node, and it's not working. Surprise, surprise. We can use, funny. This should be working. Anyways, we can use also, sorry. We can use also the terminal SDK tooling CLI and do Ipfs get. So I'll get the ID of the content, which is my website. It downloaded it basically, well, I have it stored locally, but basically imagine that I don't have it stored locally. What we would do is like ask the DHT, okay, hey, do you know who has this file? And then it will route and do all the lookup process. Then basically the file is here. We can see what's there, and it's basically the same as in here. So basically, the idea is that I just uploaded my website to Ipfs, right? The cool thing is that, let's say that there's this adversary, which for some reason wants to know what do I do during or where I am at, and this resolves, already. Okay, and wants to check, where I am at in terms of location. So a very cool way to do this is that to have this thought process. Okay, I know his website. I know his website is stored in a DHT in Ipfs. So why don't I just try to understand what's the IP or what's like the node? What's the IP of the node which is caching his personal page? The thing is that if I'm caching this personal page in this building, the person will know by requesting it that I'm in this building. If I go to Frankfurt tomorrow, this person will be able to know that the provider of the content is in Frankfurt. And with that, you can actually start sort of creating a very thorough sort of a visual map of what's happening of or where I am at. Again, very bad. So what I'm doing here is stalking myself, which this is my ID. So basically what I'm saying now is that the person with this ID, which is me, as you can see here in my nodes, has these IP addresses, right? So my script, which is here, I'm not going to go through it, sorry. But what's doing is basically every time ask, okay, where is this provider? Where is this guy? Where is this guy? Where is this guy? Now I mentioned that I change network, right? So if I change network, I have to also finish the day daemon. So by changing network, I'm just going to connect to VPN. So basically that will make me like simulate a way of, okay, I just got out of this internet provider, or I just got out of this router. Okay, it's on. I will keep the same ID because the IDs are attached to the private keys, not to the IP addresses. I'm still, again, caching the website that I just put up. And what this guy is going to do is, okay, where is the guy who is caching the website that I'm looking for? So basically, by doing exactly the same thing, I'm going to see a completely different set of IPs. And that means that if you kind of run this over time, and if you think that I can also cache content on my other mobile phone or my other devices, you can actually get a very, very good sort of a picture of what people are doing based on what they're caching, right? So that's basically another kind of attack vector. Now, I don't know if it's because I'm connected to my VPN. Again, peer-to-peer problems. I'm actually not able to.
You're just requesting the file and seeing what the source IP is.
Yes, exactly. So again, I'm the one responsible to cache the file. The network knows that. I change my IP address because I change the place where I'm at. The same person can know this my new IP address and then can sort of trace a plot of where I am at. So if you think about what Google does with your Google Maps, when you go and, oh my God, Google knows that I came here because of my Google Map locations. This is basically the same thing, but for everyone, right? So basically, everyone can know that I've been here because they cannot infer that I'm the one caching that website. And that's super sketchy. That's exactly like the idea that I wanted to pass across is whenever we're talking about peer-to-peer technologies, centralized technologies, we have to be careful about to whom are we disclosing information. Because now we're not disclosing to a central authority, but most likely we're disclosing to a much wider audience. Basically, that's it. There was another interesting, this is what I call a stalker, the stalker example. It's very good for stalking people and know where people are at and know device information and whatnot. This is not working. Cool. Anyways, I would really recommend you, though, to play with IPFS. Again, I'm a very advocate of IPFS, DHTs, peer-to-peer technologies. And I think it's very ironically that I'm using IPFS in this case because they're the ones who provide the best interaction CLI tools and whatnot. But that's why they're such a good use case in a way. Just a very cool story about BitTorrent. I had a friend who received, so BitTorrent uses the DHT as well to store content and to route lookups. Very nice anecdote, but this is happening basically everywhere. I lived in Helsinki for a long time, and a friend of mine who was working at a security company with me, he received a letter from a super weird law office saying, hey, we've noticed that you downloaded this video at this time of the day from Pirate Bay, from basically BitTorrent. And yeah, he did that, right? Because it's easy to know. And they were threatening in the letter, either you give us 3,000 euros, or we're gonna talk with Warner Bros. Or whatever movie producer, and we're gonna sue you for much bigger money than that. And the guy knows this, and the guy
knows about this, and he nevertheless paid, just in case. Now, any one of us can actually do this. Basically, you go to the mainline DHT, which is the big DHT that is running torrent. You can go there and see whose IP addresses are requesting which content. And then you basically can just create a fake letter and say, hey, I know that you downloaded this particular video at this particular time, so either you give me like 2K or we're just going to do this to you. And I mean, any one of us can do this in basically, I don't know, if you want to do this later on, we can try it out. Super sketchy, but it works because it's a peer-to-peer network, and there's no security, and there's a lot of metadata. Like, okay, there's no security, I'm over stating here, but there's no metadata protection if we're not careful enough. So yeah, that's just another example of how this is actually dangerous. Okay, so I don't have much time, so I'm just going to run, not run, but get it fast. So we're talked about how everyone is naked in peer-to-peer networks, but it's also interesting to know what are the sort of solutions for that, because I still believe that peer-to-peer is a very interesting technology, but we just need to really think more through how to sort of protect people from these metadata leaks. And again, I just wanted, before going to the solution part very quickly, I just wanted to also make sure that we're all on the same page on, again, my reason to talk about this is because I'm very, very pro personal privacy. And if we think about the world in which peer-to-peer decentralized sort of networks and services take a bigger sort of a slice of the user, kind of pie, and if it becomes a bit more mainstream, we can understand how this can actually become a mechanism to make sure that people don't demonstrate, because you can crack down on them because they've been sort of using a DHT to find their own friends who have the same type of sort of ideas against the government or ideas against anything else, and then you can actually get information about who's sort of organizing around that, try to shut them up, and I mean, just think about the cases. And yeah, that's like, basically, it's becoming more and more like this, even with the peer-to-peer decentralized systems, and especially if we're not careful enough to design and deploy peer-to-peer systems which are not metadata resistant. And that's basically what we've been talking about. Okay, so how to put some clothes on. I've got actually 5 minutes. Oh my God, I've been talking so much. How can you guys bear this? Are you not sleepy or something? Oh my God, that's cool. Sorry for this. I'm just gonna be like super quick. How can we get clothes on? It's very hard. One of the ways is onion routing. So we can actually make it so that we use a cryptographically secure sort of a routing or channels through basically creating several layers of encryption in which each of the people in the middle of the route can decrypt, see what's the content, and pass it forward. But the idea is that the relay, this relay here, there's no way he knows that the initiator was this. And the idea is that whenever you do a request, whenever you receive a request, you have no way to know, or you have no way to link the initiator with the content, because it's been through sort of a tumbler, right? So onion routing is one of the ways. It's a mess. It will make latency much worse. There's no, at least in DHTs, there are no central authorities will keep where the relays are, metrics about the relays, like we have in the onion routing, Tor. It's a similar idea, but a bit harder to do in a completely centralized way. I'm not even sure if it's good enough. Might be good enough, at least to make it better than it is nowadays, but we will get a hit on latency, performance, bandwidth, cryptography. It's going to be a bit harder to make things go. There's basically no incentives. People who are usually don't care about this. On the other hand, we also didn't care about giving so much data to Facebook, and look at what happened, right? So that's exactly why we probably want to build systems with a new paradigm in which we're able to take the lessons from the past into the new systems. Anyways, I'm so sorry. I mean, this is going to be another talk that I'm going to give somewhere else about actually the mechanisms to be sure that basically trying to solve the problems that we just talked about. This is basically like research themes. If you're interested in a PhD, if you're interested in working in these without a PhD, just talk to me. I've been working a lot with this kind of stuff. You can actually see pip3lib, it's privacy preserving protocols library. It's written in Go, and it plays very well with like libp2p and other peer-to-peer libraries. And the idea is that to create like the very modular libraries and packages that help system developers to use onion routing on top of IPFS without having to care about how to create the cryptography, how to build the cryptography to actually implement that. So that's basically already there. There's a P3, there's a Sphinx, which is a onion packet implementation, onion routing packet implementation, and there's a video coming up actually tomorrow, I hope, if I can record things on time, about exactly using the same things, the same demos we've supposedly had, which we didn't have because of the internet, but the same demos, but now with routing, onion routing, how does it look to an attacker, right? That's a super cool exercise. Anyways, there's so many other possible solutions. Super cool cryptography, super cool applied cryptography, peer-to-peer protocols, mixed nets, which are a bit of onion routing, but much better, much slower as well, friend-to-friend routing, multi-party computation, zero knowledge. There's a bunch of interesting research, development work to be done, and trying to apply that to routing and trying to apply that to peer-to-peer routing, trying to apply that to peer-to-peer technologies networks so that we don't leak all the metadata that we've seen. It's super cool. Sorry we don't have enough time. I'm actually over time already, that's crazy. Yeah, but then again, everything has a price, right? Encryption is free, kinda, but privacy is not. And people usually are not that aware of that, and we are very lazy as well, as everyone knows. There's basically no incentives for making sure that privacy is there, especially on decentralized systems, which is very sad. And that's where like cryptocurrencies can come in and give the incentives for different nodes to actually work together to not only provide the content and to provide the network capabilities, but also to provide the sort of a private layer on top of that. So basically for an incentive for a relay, right? To receive a node, a package, and forward it forward. Anyways, there's so much things to do here. It's very cool. There's not enough research nor engineering, super sad. I would definitely, I mean, it's such an interesting world, and I would definitely encourage you to take a look at it. I've got a lot of resources, a lot of ideas if you want to think about it. Yeah, the idea is that to create a system, protocols in which we have plausible deniability. So basically, if I get the data, if I'm storing some data or if I'm requesting some data, it doesn't mean that I'm interested in it. It will actually help with everything. Anyways, yeah, peer-to-peer are so hard to make it private. Why are we even concerned about this? Because centralized systems and peer-to-peer do not scale as well. And also, we're giving out too much information to them. So what we want is to have peer-to-peer networks, decentralization, but as private and secure as possible. So that's why we actually should care about P2P, even though nowadays they're super, super not private. Okay, so that's basically it. Thanks a lot. Sorry for the time. Yeah. 1 hour, what the hell? Thank you so much. You can look up or talk to me later on if you're interested in this. Thanks.